and welcome to another Senior Beginner lecture video. Today we are going over Algebra 2, and what we're going to cover is when can a system of linear equations have a solution, arithmetic operations on algebraic expressions, and finally, factorization and expansion of algebraic expressions. So before we begin, we should define what a system of equations is. So a system of equations are two or more equations in two or more variables that have the same solution. Let's look at this. This is the standard way of writing a system of equations. a1 times x plus b1 times y equals c1, and for the second equation we have a2 times x plus b2 times y equals c2. A and b in both of these cases are coefficients, or they're numbers that are being multiplied by these variables. And the variables x and y are the same for both of these equations. Now, if we were to graph this equation on a xy coordinate and this equation on an xy coordinate, they should look something like this, where they cross at a single point. That single point is actually the answer to this system of equations, where x would be the x-coordinate of this point and y would be the y-coordinate of this point. Now let's look at an example. 2x plus 3y equals 12, and 4x minus 2y equals 10. So if we were to graph both of these lines on an xy coordinate, it should look something like this, where the first one is the blue line, and the second one is the green line. And if you can see, they cross at this point right over here. And that point is 3.38, comma 1.75, where this is the x and this is the y. So let's look at another example. 2x plus 3y equals 12, and 4x plus 6y equals 24. Now if we actually look at this really closely, this equation is just this equation, but it's being multiplied by 2. As you can see, 2x times 2 equals 4x, 3y times 2 equals 6y, and 12 times 2 equals 24. That means that when we graph this on an xy coordinate, they're both going to be on the same line. For example, this would be one line, and this equation would be another line, and they'd be directly on top of each other. That basically means that every single point on those two lines will intersect, which means that these system of equations have infinite solutions, where any x can equal any x and any y can work for both of these solutions, both of these equations. And to check, we can use this right here, where we put the coefficients, or the numbers that are being multiplied by the variables, over each other. And we can also put the solution over each other. So, a1 over a2 equals b1 over b2 equals c1 over c2. If this is all true, then that means this system of equation has infinite solutions. So let's check. 2 over 4 equals 1/2, 3 over 6 equals 1/2, and 12 over 24 equals 1/2. So 1/2 equals 1/2 equals 1/2. That's true, which means this system of equations has infinite solutions. Next, let's look at this example. 2x plus 3y equals 12, and 4x plus 6y equals 30. Now if we graphed both of these equations on an xy coordinate, it would look something like this, where the first one would be the blue line and the second one would be the green line. Now if you look here, both of these lines don't intersect. In fact, they're parallel and they're never going to intersect. They're just going to keep being next to each other forever. Now if you remember the definition of a solution, it's whenever two lines met and that coordinate where it intersected, that was the solution, or the x would be the x-coordinate and the y would be the y-coordinate. But if both of these lines never intersect and they're always going to be parallel, that means that there are no solutions. So a way we can check this is by doing this. We put the coefficients over each other again, but this time we're going to have it not equal to c1 over c2. So let's try. 2 over 4, or a1 over a2, is equal to 1/2. Then 3 over 6 is equal to 1/2. But 12 over 30 is not equal to 1/2. So that shows that there's actually no solutions to this right here. So in summary, a standard form of a system of equations looks like this, where a1 times x plus b1 times y equals c1, and a2 times x plus b2 times y equals c2. And if these conditions are true, when a1 over a2 equals b1 over b2 equals c1 over c2, then the system of equations has infinite solutions. But if a1 over a2 equals b1 over b2, which does not equal c1 over c2, then the system of equations has no solution. Okay, let's move on to arithmetic operations on algebraic expressions. So if you want to add or subtract two algebraic expressions, what you want to do is group like terms, or look at same variables and same degree, and then add or subtract the coefficients. So let's think about this in one way. Let's say I have a cart full of fruits, all different types of fruits, all different types of colors. And what I want to do is sort them by color before I add them into a fruit salad. So what I'm going to do is put all the red fruits in one basket, put all the yellow fruits in another basket, and then put all the green fruits in a different basket. So there I have combined all the like terms. So let's apply that concept over here. So let's look at our first algebraic expression and our second algebraic expression. So what we want to do is look at the variables. So this first algebraic expression, the variables, or basically the letters, are x, y, and z. But x and x are the same thing, so our variables are going to be x, y, and z. And then for our second thing we're going to look at is the degree. That basically means you want to look at the exponent, and if two terms have the same variable, but they have different exponents, what you want to do is look at the higher exponent. So if we look here, x is raised to the third power, and here 4x is raised to the second power. But since 3 is higher than 2, we're going to look at this x to the third power and say that x is going to be to the third degree. Next, we're going to look at our next variable, which is y. And since y is not raised to anything, we know that it's automatically the first power, because any number to the first power is that number. And same thing with z. It's going to be to the first degree. Next, we're going to look at our second algebraic expression. So here x is raised to the fourth power, and it's higher than this one, x to the third power, so that means that x is to the fourth degree. And then if we look here, the z is going to be to the first degree. And then our variables for the second expression is just x and z. So variables are x and z. Now what we're going to do to add these two expressions is we're going to line up all the like terms together so that when they add, you're just adding directly down. So if we look here, we're lining up the third degree to the third degree, second degree to the second degree, and then first degree to the first degree. This doesn't have anything, so here. And whenever the second expression doesn't have any matching terms to the first expression, we're just leaving a blank, which means we're just going to directly add this down. So when we add both of these expressions, we get x to the fourth power plus, see here, 4x to the third power, and you see here, 6x to the second power plus, you see here, 3 times y plus 6 times z plus 30. So now let's move on to multiplication of algebraic expressions. So when multiplying algebraic expressions, we use the distributive property and then combine like terms. So for example, we want to multiply this algebraic expression with this one. So what we want to do is multiply every term from the first algebraic expression to the second algebraic expression, and multiply every single term from that one to every single term on this one. So for example, we want to multiply this x to the x squared, to the x, and to the 1, and we want to multiply this minus 1, or this negative 1, to the x squared, to the x, and to the 1. So to do that, what we want to do is break up this expression and say that x times the second expression minus 1 times the second expression. And when we actually use the distributive property and distribute and multiply this x throughout this expression, we get x times x squared plus x times x plus x times 1. Then you do the minus, and we want to multiply this 1 times this expression. So 1 times x squared plus 1 times x plus 1 times 1. And then once we simplify, we get x to the third power plus x squared plus x minus x squared plus x plus 1. And what we want to do is apply what we learned in the last concept, which is adding algebraic expressions, adding and subtracting algebraic expressions. And what we want to do is line up the like terms so that they can subtract nicely, and we'll get our answer. So we have no like terms for this, we just have x cubed. Then we have these two like terms, x squared, so x squared minus x squared, that's 0, so there's nothing there. Then we have x, so x minus x, nothing. And then we have plus 1, but we're subtracting it, so we actually have minus 1. So our final answer is x cubed minus 1. So now let's move on to the division of algebraic expressions. So when dividing algebraic expressions, we're going to use long division. So let's say we want to divide this expression by this expression. So what we're going to do is set up as a long division. And when we start with long division, what you want to do is see, okay, what times this is going to equal this. So we're only going to consider the x when we're doing long division. And then we're going to still use the negative 4 or the minus 4 for our math. So what times x is going to equal x cubed? Well, x squared. So x squared is going to be written up here. So now we continue to the next step of long division, which is multiplying this by this. So x squared times x equals x cubed. And then we're also going to consider this minus 4. So x squared times minus 4 is equal to minus 4x squared. And then the next step of long division is to subtract. So we're going to subtract this. But when we subtract this, this is going to be negative and this is going to turn positive. So we're going to bring this down. This is 0, and then we're going to do this. And this is going to give us 2x squared. And then our next step of long division is bring down. So we're going to bring down the next term, and we get minus 4. So now we have 2x squared minus 4. Now let's move on to the next step of long division. What times this is going to equal, this? So x times 2x is going to equal 2x squared. So we're going to write, and because it's a positive, we're going to write plus 2x. So now let's do the next step, which is multiply. So 2x times x is going to equal 2x squared. 2x squared. And then we're going to also consider this minus 4. So what's 2x times minus 4? Well, that's minus 8x. Okay? But when we subtract, we have to remember that these two are not like terms. So we have to make sure we just don't subtract these down because they're not like terms, you can't do that. Also, remember the minus, this is going to turn negative, this is going to turn positive. So when we do the subtraction, we actually get 8x. And because this is not a like term, we're just going to add it to the end, minus 4. So we have 8x minus 4. And now we want to apply it to this again and see what multiplied by this is going to equal this. So 8. 8 times x is going to equal 8x, so let's do plus 8. So we get plus 8. 8 times x minus 4 is going to equal 8x. Now we have 8 times negative 4, that's going to equal minus 2. And then when we do this turns plus, and what we get is a remainder of 28. So our answer is going to be this expression right here, x squared plus 2x plus 8, and we have a remainder of 28. So next let's look at expansion. So let's say we want to expand this expression right here, a plus b squared. So remember, whenever we're squaring something, we're just multiplying two of the same thing. So this is written in a little bit more of expanded form is a plus b times a plus b, both in parentheses. So one method we can use is the FOIL method, and this is really common for whenever you have to square algebraic expressions like this. So what we do is we look at the first terms and we multiply those. Then we look at the outside terms, we multiply those. We look at the inside terms, multiply those. And then we look at the last terms, hence FOIL. So a times a, just the first terms, plus a times b, which is the outside terms. Then plus b times a, which is the inside terms. And then we have b times b, which is the last terms. Alright? So if you remember the commutative property of multiplication, we know that a times b and b times a are essentially the same thing. So this means that this is pretty much a times b plus a times b, which is equal to 2ab. So if we simplify, we get a squared plus 2ab plus b squared. Now another way we can do this is by using the multiplication rules that we used last time for multiplying algebraic expressions, where we pretty much break this up and do a times the second expression plus b times the second expression, and we get the same answer. And don't forget to combine like terms and be really careful, make sure you don't combine the wrong terms together. So now let's try expanding this expression right here, a plus b to the third power. So what we're going to do is we're going to break it down into stuff that we know. So we know that we can do a plus b, and we know that we can do a plus b squared. So since we already got a plus b squared, I'm just going to plug this in here and then do it times a plus b. And then what we can do is use the multiplication rules that we learned earlier and pretty much break this up, multiply the terms from this into the terms from this. So we're going to do a times the second expression plus b times the second expression. And after we combine like terms, we're going to get a to the third power plus 3a squared b plus 3ab squared plus b squared. So now let's try two examples. Let's try a minus b squared. So to do this, we're going to expand it a little. Do a minus b times a minus b. Then I'm going to use FOIL, and we're going to do a squared minus ab minus ba plus b squared. and then combine like terms, and we get a squared minus 2ab plus b squared as our answer. Next, let's look at this example, a minus b to the third power. So what we're going to do is break it down into terms that I know. So I know a minus b, and I know it's times a minus b squared. So what I'm going to do is plug in what I got for a minus b squared, which is this, in here. And then I'm going to use the multiplication rules and break this up and do a times the second expression minus b times the second expression. And after I get all the terms and combine all the right terms, I get a to the third power minus 3a squared b plus 3ab squared minus b to the third power. So now we're going to look at factorization. So one way to factor is by using the quadratic equation. Now a quadratic equation has this standard form: ax squared plus bx plus c equals 0. Now it's really important that it equals 0. So what we're going to do is take the coefficients and apply them into this formula right here, which is the quadratic formula, where x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. It's a good idea to memorize this equation because it's used in a lot of areas in math. So, for example, we have this equation right here, x squared minus 5x plus 6 equals 0. So we know this is a quadratic. Then we need to find out what a equals, what b equals, and what c equals. So a equals 1, b equals negative 5, I see in here, minus 5, and c equals 6. So now we're going to plug it into the quadratic equation. So minus, and then in parentheses, negative 5, plus or minus the square root of b squared, so negative 5 in parentheses squared, minus 4, and then times a, which is 1, times c, which is 6, all over 2a, which is 2 times 1. And then we get 5 plus or minus 1 after we solve this square root here. And then 5 plus or minus 1 over 2. So we're going to try one method, which is 5 plus 1 over 2, which is 6 over 2, which equals 3. And then we're going to try 5 minus 2 over 2, or 5 minus 1 over 2. So we do 5 minus 1 over 2, which is 4 over 2, which is equal to 2. Next, another way we can look at factorization is by knowing the standard forms of other factors. So we have this standard form here, a squared minus b squared, and its factorization is a minus b times a plus b. Now if we actually multiply this out, we will get this answer. So it's really important that you know this standard form so you know easily that this can be the factor form. Alright, so next let's look at this factored form. A to the third power plus b to the third power. So the factorization for this is a plus b times a squared minus ab plus b squared. So the reason we know this is because we know that a plus b cubed is equal to this form right here. So what we're doing is just moving the form around and making sure it works for this form. So a to the third power plus b to the third power equals a plus b to the third power. Notice that these two are very different. Minus 3ab times ab times a plus b in parentheses. Remember, these two things mean the same thing. And we get a plus b in brackets a plus b squared minus 3ab in close brackets, and we get a plus b in parentheses a squared plus 2ab plus b squared minus 3ab. And then we get a plus b in parentheses times a squared minus ab plus b squared. So a quick note about the quadratic equation method or the quadratic formula method. Whenever you're using the quadratic formula, what you're finding is the values of x, but what we want to find is the factorization. So using these values of x, we can find the factorization. So the reason that we put it in this way is so we know what the factors are for this equation right here. And the way we can find that out, the way that we know that from x equals 2, we can put x minus 2, is by doing this. We know that x equals 2, but what we want is this whole equation to equal 0, just how this equation equals 0. So what we're going to do is try to make this side 0, and this side have all the numbers and the x. So what we do is do minus 2 over here, and then minus 2 over here. So we get x minus 2 equals 0. Same thing we do with the x minus 3 or the x equals 3. We know that x equals 3, but we want this side to be 0 and this side to have the x and the factorization. So we do minus 3 over here and then minus 3 on this side, so we get x minus 3 equals 0. So this is our factorization. Okay, so now let's apply our knowledge using an example. So 2 years ago, Jean was 9 times as old as Carol. He is now 7 times as old as she is. how many years from now will Jean be 5 times as old as Carol? So I want to break this problem into 2 parts. The first part is trying to find the current age of Jean and Carol. And then the second part is the question, what the question is asking, which is how many years from now will Jean be 5 times as old as Carol? So for solving the first part, we're going to use system of equations. So I want to first figure out my variables. The age of Carol, I'm going to make equal to C. And the age of Jean, I'm going to make equal to G. So next, I'm going to set up my actual equations. So it says 2 years ago, Jean was 9 times as old as Carol. So 2 years ago, which is Jean's current age, G, minus 2, is going to equal 9 times C, which is Carol's current age, minus 2, since it was 2 years ago. So now this equation makes sense. Now we're going to go to the next equation. He is now 7 times as old as she is. So Jean's current age is equal to 7 times Carol's current age. So now we're going to use one of the 2 methods to solving a system of equations. And I'll go over the specific way to do these 2 methods a little bit later. But we're going to use substitution in this specific question. So basically for substitution, what we're going to do is we're going to substitute a value for a variable using the variable equal to other terms. So what we're going to do is we're going to try to find, let's see, for G, what we can make G equal using these other terms. So conveniently, this is already given to us. We know that G equals 7C. So I can substitute whatever G is with this, 7C. So I'm going to do that, I'm going to put 7C instead of G over here. And then I get 7C minus 2 is equal to, and then multiply this out, 9C minus 18. Now I want to bring my variables to one side and my numbers to the other so I can figure out what the variable equals. So to do that, I'm going to do minus 7C here, or the opposite operation, to get rid of the 7C on this side, and then whatever I do to this side, I have to do to this side. So I do minus 7C here, and what I get is 9C minus 7C, which is equal to 2C. And then on this side, what I'm going to do is I'm going to add 18, which is the opposite operation, and then I'm going to add 18 here. So negative 2 plus 18 is going to equal to 16. So I get 16 is equal to 2C. Then I'm going to divide this side by 2, divide this side by 2 to get C equals 8. And then from then, I'm going to substitute again whatever I get for C, which is an actual number this time, and substitute it into one of these 2 equations. I'd rather do the easier one, so that's going to be the second one. So I'm going to do 7 times whatever we got for C, which is 7 times 8, is equal to G. So I get 56. So Jean is currently 56 years old, and Carol is currently 8 years old. Now, to do the second part, I want to do this. I want to figure out the amount of time until Jean is 5 times as old as Carol. So I'm going to make that into a variable, t. And what I'm going to do is I'm going to say, okay, so Jean is 56 years old. So whatever time we add is going to be the same as 5 times 8, which is Carol's current age, plus the amount of time it's going to take for her to be 5 times the amount of Jean's age. So then what I do is I just try to multiply this out. So I get 56 plus t equals 40 plus 5t. Then I'm going to bring my t to one side and then bring all the numbers to the other so I know what t equals. So what I'm going to do is the opposite operation. So this is 40. So I'm going to do minus 40 to this side to get rid of the 40. Then minus 40 on this side, so 56 minus 40. And then on this side what I'm going to do is I'm going to do 5t. I'm going to do minus t over here to get rid of the t here, and then minus t, so I get 5t minus t. So I get 4t is equal to 16, so t equals 4. Okay, so these are the 2 different ways of solving a system of equations. So the first way is substitution, and that's what we did for this problem. So let's look at this system of equations. It's just going to be these 2, x plus y equals 7, and 2x plus y equals 4. So what we want to do is find what x equals and find what y equals. So the best way to do the system of equation problems, not like this, but a different type of, like the standard system of equation problems, is to make sure that they are in the standard form. So this is the standard form here, x plus y equals a number, and then x plus y equals a number. So what I'm going to do is try to make either x equals something in the other terms of the equation, or y equals something. So this time I used x. So what I did is I moved this equation around so that it looks like x equals 7 minus y. So the way I did that is I subtracted y from this side to get rid of it, and subtracted y from this side to make 7 minus y. Then since I know x equals 7 minus y, I substituted that into the second equation. So for x, I put in 7 minus y. So it's 2 times 7 minus y plus y equals 4. So the goal is to make sure that there's only one variable on this equation so we can actually find what number that variable is equal to. So after I do some math and I do the multiplication for this, I get 14 minus 2y plus y equals 4. Now, what I do is I put the numbers on one side and the variables on the other, so I eventually get negative y equals negative 10, so I know that y is equal to 10. Then I go back and I substitute this back into an easier equation, whichever one's easier. This time it's the top one. So I do do x plus whatever y is, so y equals 10. X plus 10 is equal to 7. So then what I do is I find x, and x is equal to negative 3. Now another way to do this is elimination. So I have the same question, x plus y equals 7, 2x plus y equals 4. That's my system of equations. And what I want to do is I want to basically eliminate a variable so then I can find the other variable's numeric value. So what I'm going to do is I'm going to manipulate one of these equations so that when I add them together, it's going to eliminate the common terms and then eliminate the variable. So what I can do is, because I know this is 2x plus y equals 4, I can try to make this top one x something minus y equals something. So then I know that when I add them, the minus y and the plus y is going to cancel out, so I'll only have x's left. So to do that, what I'm going to do is multiply this whole equation by negative 1. So when I do that, when I multiply all of these individual components by negative 1, I get negative x minus y equals minus 7. Then I'm not going to change anything for the second equation. Just put it right here. And I'm going to add them together. And when I add them together, straight down, I get x is equal to negative 3. And remember, the minus y and the plus y cancel out. So I get x equals negative 3. Then what I do is I substitute this back into an easier equation. Looks like it's the top one. So I put negative 3 plus y is equal to 7. And I find what y equals, and y is equal to 10. Now it's important to remember that whenever you do either one of these methods, when you get something like that doesn't make sense, for example, if you get like 52 is equal to 10, then that means that the system of equations has no solution and the lines don't meet. And if you get the same answer, for example, you get 5 equals 5, you get x equals x, something like that, that means that it has infinite solutions or every solution works. Let's try 2 more examples to master our ability to factor. So let's factorize 4x squared plus 4x plus 1. So if you look at this, you'll actually see that it has very similar structure to this right here. A squared plus 2ab plus b squared, which we've already studied before. It's a perfect square. So the factorization of this, as we learned, was a plus b times a plus b. So what we have to do is just restructure this so we figure out what a is and what b is. So what we're going to do is write this in this form so then we can figure out a and b. So I've expanded this equation, or this expression right here, 4x squared plus 4x plus 1. And so we know that a squared has to equal to the 4x squared. And we know that the 2ab has to equal to 4x. And we know that the plus 1 has to equal to the b squared. So what we do is we just add these in. So we do 2 right here. We know that 2x, if 2x squared is squared, it equals to 4x squared. So a must be 2x. Now to figure out b, we should do something squared is equal to 1. And what squared is equal to 1? 1. So 1 squared is equal to 1. 2x squared is equal to 4x2. We don't really have to care about this because we already have our a and our b. So we know that the factorization is going to be the same structure as this. It's going to be 2x plus 1, 2x plus 1. So our factorization is 2x plus 1 times 2x plus 1. Now let's do this. Factorize a cubed minus b cubed and a to the 4th power minus b to the 4th power. So to do this, it's really important to remember special factorizations, and what you should do is maybe look up special factorizations and try to memorize all the common special factorizations so you can easily see like a big factorization and just break it down into just like its special factorization. So for a cubed minus b cubed, this is actually the factorization, and it's really important to know this because you'll need it for like other to factorize other expressions that might be much bigger or much harder. Alright, so also to check, you can always multiply this out and you'll get this answer. So now let's look at a to the 4th power minus b to the 4th power. So let's break this down. Since we know, and an important part is we're going to break it down into stuff we already know. So since we know that a squared minus b squared equals a plus b times a minus b, we can just implement this into here. So we also know that a to the 4th power minus b to the 4th power is equivalent to a squared squared minus b squared squared. So do you see how we turned this into this, and we just substituted when a equals into something else, a squared, and when b equals into something else, b squared? So now that we turned this into this, we can see the factorization. So what I did is I did a squared squared minus b squared squared, and since each term is squared, we can make the whole thing squared, so we get a squared minus b squared equals a squared minus b squared whole squared. And this looks very similar to this. So now I'm just going to apply the factorization from this into this. So I know a squared plus b squared times a squared minus b squared is the factorization. And then I have to keep simplifying to find the real factorization. So I know a squared plus b squared, that's just going to stay because there's no factorization for that. But I know that for a squared minus b squared, there's factorization. So I factorize again, and I get a squared plus b squared times a plus b times a minus b.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramatcircle.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email but without the info and the end. So bye!